We're going to start now this lecture on ecosystems and nutrient cycles. And to start with, we're going to discuss, we're going to go back to recall the planetary boundaries to remind us why these concepts are very important. So we have said before that changes to ecosystems due to human activities have been more rapid in the past 50 years than any time in the human history. And this can lead to irreversible changes, right? And the main drivers are the demand of food, water, and natural resources, causing severe biodiversity loss and leading to changes in ecosystem services. Ecosystems are highly affected by the land use change. This is one of the main driving forces, reducing biodiversity and having impacts on other boundaries, such as the phosphorus and nitrogen boundaries, and also other biochemical cycles, such as the carbon cycle and the water cycle. To start talking about ecosystems, we're going to start discussing key points. One of the key points is that an ecosystem consists of a community of organisms together with their physical environment. So these are communities of organisms that interact with each other and that also have interaction with other other energy and matter sources, such as the sunlight, rainfall, and soil nutrients, right? The ecosystems can vary greatly in size, and so they can be, for instance, also be marine, aquatic, or terrestrial. And we have when we are talking about broad categories of terrestrial ecosystems, we will talk about biomes. All right. So in ecosystems, both matter and energy are conserved. Energy flows through the system, usually from light to heat, while matter is recycled. Another key point is that ecosystems with higher diversity tend to be more stable with greater resistance and resilience in the face of disturbances or disruptive events. And we're going to talk now about the concept of resistance and resilience to understand this. Ecosystems are dynamic systems, and if these systems will become static, that will mean that they will be dead, all right? And equilibrium is a steady state of an ecosystem in which its composition and identity remain generally constant despite fluctuations in physical conditions and the makeup of the biotic community. Ecosystems may be knocked out of equilibrium by disturbances. Can you think of what type of disturbance can affect an ecosystem? So some disturbances are the result of natural processes, and some others are human induced. So, for example, fire is a disturbance that can be caused by lightning, and or can be caused by human activities, right? But for example, deforestation or alga blooms or the introduction of invasive species is a disturbance that has been caused mainly by humans, right? So the different ecosystems may respond differently to the same disturbance. They can recover rapidly, or they can recover very slowly, right? So that's why we will talk about resistance and resilience. So these two parameters means how an ecosystem responds to disturbance. These parameters can help us to know whether there is still equilibrium in the system or not. So, how the resilience means how rapid an ecosystem returns to equilibrium after it has been disturbed. And within this concept of resilience, we're going to talk about biodiversity because it has been known that high biodiversity leads to higher resilience in a system. All right. To further understand resilience, we have used this figure that is on the left side, which is called the basin of attraction model. And this illustrates how a community, which is the ball, can reside on one basin or another, or can move to a different basin. And these basins have different wide size, and this represents the capacity of these basins to maintain equilibrium conditions. The relevance of using these type of models is that we recognize that ecosystems are not static and can transit among other states, and that we can have ways of assessing how easy or how difficult it is for these ecosystems to be disturbed. So now we're going to discuss how these ecosystems can be affected by the change of the land cover. The change in ecosystem functioning is caused by these changes in land cover and also the changes in ecosystem structure. These can also lead to cascading effects, which are related to changes in climate change, biodiversity, and also changes in biogeochemical cycles. So we're not going to go into detail in the changes in ecosystem functioning, because these are related to the biochemical cycles that will be discussed later. And we're going to focus now on the changes in ecosystem structure. So these changes are, for instance, the change of one forest to agricultural land that can lead, for example, to changes in albedo and roughness, or that can lead to changes in fragmentation and soil structure. In terms of albedo and roughness, this is very important because it affects the climate system, and this is affected through the reflectance or absorption of incoming solar radiation that we discussed previously, and also it can drive to changes in wind flow due to the changes in roughness. Another change in the ecosystem structure is fragmentation. And the fragmentation leads to changes in the biodiversity. But these changes are very complex, because in some cases it can increase the overall biodiversity when we're talking about small species. But there are some other species that require large areas of habitat, and they require to have connectivity to survive. A clear example of this is what happens in many regions in Africa, where large herbivores rely on migration pathways. They use these to track seasonal changes in climate and water availability, and also the availability of food related to the grasslands. So in recent decades, with the agricultural expansion, there has been an intensive fragmentation that has cut migratory pathways and has affected it has led to extinction of some species. When we talk about the changes in soil structure, we need to connect this with the importance of the soil organic matter in soil. This is what maintains the soil structure characteristics. And this is very important because it allows the retention of water and the retention of nutrients. So it is an important component on maintaining the carbon cycle within soils, because soil structure can maintain microbial activity that allows for degradation of organic matter coming from dead plants and material that falls into the soil, right? And then there is the worst case scenario when there is soil erosion that can lead to other significant problems, and also to the final, completely loss of soil that will not allow for growing new vegetation and maintaining the ecosystems.